Welcome to the Python for Data Science workshop. If you have questions during this, and if you're live, do feel free to raise your hand at any time. And to raise your hand, you can go to a couple of different ways. You can go to Reactions and just click on Raise Hand. And that will actually put you to the top of the participants list so I can see that you have a question. And I'll be able to lower your hand as needed. In the breakout rooms, if your breakout room would like to have someone visit, we're going to be doing a number of those. You can ask for help there. That'll notify me, and one of us will go in to help you in the breakout room. This will be recorded. This is available on our GitHub channel. We also have all of our videos, all of our other videos up there available as well. If you can, do try to attend in person, of course, because the breakout rooms don't get recorded, so you'll get the full experience if you actually are participating live. If you do have questions, we should be able to answer many, but maybe not all questions. If there are technical questions or if you have access questions for Colab, we think that by using Colab, we're going to settle a lot of the more intensive technical questions that you can run across when you're trying to install Python on your local machine. But just know it's possible. We may not be able to get everything. If that's the case, remember, we do have this recorded, so even if you have to solve a problem a little bit later, you'll always be able to go back and watch the workshop. I'd also like to point out, I see many of you are going to be are already signed up for our workshop for next week, but let me go ahead and share that. This workshop is Python for deep learning. And this particular workshop, we're going to be emphasizing working on transformer-based models. So if you go to our webpage, which is simply vanderbilt.edu, data science, you go to events and you go to data science workshops. Right at the top, you'll see today's workshop. You'll also see deep learning with Python as our workshop for next week, Monday through Thursday of next week. You do have to apply to attend to this workshop. We have limited seating there. But if you have an idea for a data science project that might be appropriate, go ahead and fill that out. Even if you're unsure, go ahead and fill out that application, because we're trying to encourage as many data science projects using deep learning across Vanderbilt as possible. So please do go ahead and feel free to fill that out. If you would like to set up a session with us to discuss more in depth, I'll be putting in a link in just a moment for you to set up a time to meet with us to talk about data science projects in more detail. Matter of fact, I'll go and I'll put that into that Slack. I'm sorry, I'll put that into the document in just a moment so you can have that handy. So before we go, let's go ahead and do a quick check. If everyone could give me a raised hand, so we can just make sure that everyone knows where the raised hand is. Yes. Excellent. Very, very good. I'll give the other folks a chance. Oh, Mubarak, you gave me a thumbs up. Very, very cheeky. Okay. All right. And again, the hands up is going to be under the reactions. Great. Now go ahead and take a moment and lower your hand. Excellent. Know that there are other things that we'll ask too. Sometimes we'll say, give me a check mark, which is also in that same space where you can simply give a check mark. We'll ask for different responses, you know, like give me a red check, give me a red X if you're having trouble. So primarily we'll be asking, are we good? Go ahead and give me the green check if we're good. Give me the red check if we're bad. If you have a question, raise your hand. And great. And Phyllis, Akash, and Connor, I'm assuming you don't have questions. So I'm going to go ahead and show you that I can lower your hand for you, just like that. Excellent. All right. Before we dive in, before we get started, are there questions? All right. Then I say, let's go ahead and get started. Dr. Bell.
All right, fantastic. Well, good morning. As Jesse said, I'm Charo Bell, and I'm the Senior Data Scientist at the DSI. Welcome to our workshop today. The focus of today's workshop is really going to be about building foundational skills in Python, particularly as it applies to deep learning and deep learning packages. So today we're focusing on basic programming in Python to give you the tools to understand the examples that you'll see and some of the packages that we'll be using. So you'll also be able to extend the work that you're learning today and next week. We'll also be really focusing on how you can access your data and manipulate it to get it in a form, work with the deep learning models. So how to read them in, how to use them, and how to organize them. While we're doing this, you're going to see us use Pandas, which is the premier package for data analysis in Python. But this course is not going to be, or this workshop is not going to be super focused on doing data analysis. It's going to be more about using that package to manipulate your files or your text to be able to get them into a manageable and easily workable form. We'll also talk a little bit about object-oriented programming. So I think sometimes that scares people, but don't worry. Really, our objective of learning about OOP, so object-oriented programming, is to be able to leverage the power of the APIs, specifically as it works with Google Colab. And so you'll see some really cool things through Google Colab, and it'll help you to understand object-oriented programming and these deep learning packages a little bit better. So today we're going to be going into like a lot of breadth. But there are a lot of exercises that are going to be left for the reader. We've provided a lot of resources and added some exercises in general for you to code to be able to learn about each individual topic a little bit more. Try to do those every night if you can before the next class, because they're really focused on getting you to think about what we'll be talking about in the next class. So lastly, we're going to be doing a lot of coding together. Hang in there with me. You'll see that we have a little bit of an aggressive schedule. I tend to super press on the gas while I'm teaching, just so we can cover all the topics. So, but if we run out of time one day, we'll just extend that to the next day. And if I'm going
recorded as well. Did I mention it's going to be recorded as well? So just keep that in mind. You can always raise your hand and say, can you do that again? But we also record, so.
That is a great point. Okay, and so also if you happen to fall behind as well, there is the recording, but we've also provided the solutions for you right in the repo that we're going to be using. So you can always look there if you need a little bit, or you just want to catch up right quick. And I think that's all I kind of wanted to tell you to get started. Before we fully jump in, can you give me a thumbs up if you've programmed before in any language? So, but like programming languages. So like C or C++, C#, Java, R, anything like that. Let's see about how many people. Uh-oh, I can't see. Jesse, are you able to see how many people?
Yes, it looked like we had about 25. So a good percentage.
Okay, gotcha.
Over half.
Good, good. Good to know. Well, we'll be going a lot over like fundamentals of Python. So you'll see like for loops, you'll see if statements, list comprehensions. So just hang in there with me. And if you need me to slow down just a little bit, just let us know. Okay, so let me send you the link to the repo. And actually, I'm going to go ahead and just start by sharing my screen. That'll probably just make things easier. And let me know if you, oh, and I don't think I can share my screen right now. In the meantime, let me send over this link. All right, so this is the link to the workshop materials. And I put that in the chat. All right, it looks like I still can't share my screen.
And if you need to reboot, let me know.
It's saying to me that host disabled participant screen sharing.
Oh, because I'm an idiot. Here you go. You are now.
All right, there we go. All right, sharing screen. All right, there we go. So does everyone have access to the repo? Can you guys see those things there? Everyone, okay, things are looking good. Sorry, I'm just going to expand the screen a little bit. I like to look at you guys, not to make sure, you know, when you nod if things are seeming good or if they're seeming bad. So please feel free to turn on your camera. We're all friends here. We're all friends here, don't worry. Okay, so here we are in the repo. These are all the kind of things that, so these are all notebooks. You can see they all end with I, P, Y, and B. That pretty much stands for IPython notebook. These are going to be some files that we're going to be using in the next couple days. They're going to be like text files, so you can learn how to manipulate them. And everything else that you need to know is pretty much in the README. So here is our schedule. Again, like I said, it's a little aggressive there, but I think we'll be able to cover things. Lastly, here's the link to the breakout room if you happen to need it. It will always be here on the repo. Here are some instructions about doing your homework assignments. And lastly, here are some exceptional resources for learning more about Python, particularly this whirlwind tour of Python and this software carpentries tutorial. These two are used pretty heavily in developing this material, so they'll look really familiar. Okay, so now what we can do is actually open one of these repos. As Jesse said, we're going to be using Google Colab to kind of standardize this for everyone. And what we can do is just go ahead and click on this badge right here. So, whoops, I'm going to actually try that again right quick. Sorry. There we go. All right, so I just opened that in another tab.
Right, and a quick question. If we could give a go and give a thumbs up if you were able to if you were able to click Colab and start up a Colab session. Okay. Excellent. Go and give a red X if you were not able to. Excellent. No red X's.
All right, great.
One red X. Okay, great. Lee, I will check in with you in just a moment. Any other red X's? Or are we good?
Fantastic. So let us go ahead and click on this 0. This is something that if you're not familiar with programming, you're going to want to really read over this tonight and try to experience it. So let's click on this one, but it's going to be a brief review over data types in Python, but you will see them so much during when we're programming that they'll become familiar. At the same time, I'm actually going to roll back right click. I'm going to do this again.
Yep. So yeah, if you can sort of do it slowly again, just to sort of show people what it looks like. So, and so let me just walk through, just make sure. So you are on the repo right now, and the link to the repo is in the Google Doc as well, and also in chat. So then what do? You click on the Open in Colab.
Yep, and I'm just clicking Control click, so it'll open another tab. But you can just click on it and it will open as well.
Okay.
I would love to get rid of this little bar here, but it really wants to be here.
You can drag it down to the bottom if you need to as well.
So, at the same time, I'm also going to open this one. So Python Basics. This is the workbook that we're really going to be in today. So you can open that up as well. Or you can wait, whichever you prefer.
So Charo, I'm going to create a quick breakout room for those who have had trouble, because we just have a few folks who had trouble. I'm going to see if I can help them out. I'm going to go ahead and ask people to go into room 1, and let me go, and I need to recreate these. Give me a quick moment, and I need to change the options. So anybody who would like to meet me in room 1, you should be able to choose your room I need to open up the, I'm going to open up the rooms. It's going to say you're invited into a breakout room. Don't go, but do go to room 1 if you need to have some assistance in getting this running, all right? So I'm going to open all rooms. And if you're interested in some help, meet me in room 1 and I'll be over there. Also, if Preston, if you can meet me in room 1.
Notebook looks like for Python. This is how we tend to do our literate programming with our coding.
All right, great. Ria, if I'm going to go ahead and make you a co-host just for a moment so you can, let's see. Oh gosh, you may not be able to, I can't make you a co-host here. Let's see if I can do that with, it's always a bit of a challenge. I'm going to make it so you can share your, give me one moment. I'll need to pop back up to the main room. I'll be right back.
Let's see, beyond that, so you can read over these things a little bit, but there are some different types of cells. So for example, again, these are markdown. These are code cells. And so these are cells that will actually execute. And what happens is when you execute them, they go into this backend that's called the kernel, and that's where all of your computation is kind of stored. So for example, if we want to store the number 4 into this variable called var, we can just
I actually just figured it out. So it took me a little bit of time, but I got it.
Let's go back to the main room. See you there.
Perfect.
All right, and you don't really see anything there. That's because there was nothing output. The output really went into var. So if we want to look at the variable value, we can always print that variable. So let's put this. So that will execute, and now you can see 4. So the number 4 was stored into var, and all we did, quick equal sign, var equals 4. The end. Okay, so you learned 2 things just then. You learned about that we can actually use many, you learned many things. So you learned that we can use print to print the value of variables and how we can store variables, but we also learned that we can store integers into variables. But there are lots of different variable types that we can use. So for example, we had before 4, which is an integer. How can we find that out programmatically, the data type? Sorry, someone asking a question? Oh, okay. Okay, so if we want to programmatically find out what the data type of a specific variable is, we can just use this type function. So this is a function that's provided through Python. And the way that we use functions is we type the name of the function and then put the argument, so that's this I, within parentheses. So we're calling type function on this variable I. And the purpose of the type function is to reveal the type of the variable. So we can see here, once we do that, we see that that one is an int. There are all other data types, so like string. So you can see the way that we indicate that something should be a string. We wrap it in these single quotes. Alternately, we could wrap it into double quotes. So we're taking this string, we're storing it to S, and then we can take a look at what data type it is by using this function, and again, passing the argument into the parentheses. So we can use string. We can also see that we can store floating point numbers as well. So are there any questions about that? Okay, great. So we're actually going to have you to review this. So to show that, I just double click that. Sorry, just exclude that one. So we are going to have you look into this yourself a little bit more about the operators. But here are just some things that you could think about. So Python can act as a computer in general, so as a calculator actually. So any operations that you would normally do, you can do with Python. So you can add things together. So we stored 5 and 2 into these variables. We just use the plus to add those together, minus to subtract, multiply, divide, all that good stuff, put them together, order of operations, all those good things. Also, hold on, let's get there. We can do comparison. And so if you're familiar with programming languages, that basically means you can take two things and determine their relationship. So just like you learned in school, you might want to know whether something is equal to a value. So we have this variable a, which we know is equal to 2 because we set it here. And we can run that if we like. We'll just run that. And this here is a comparison operator, meaning that we are going to try to check and see if the value that's stored in A is equal to 2. And so when we're looking at comparison, it'll tell us whether the statement is true or whether the statement is false. So thumbs up if you think, so we just ran this, thumbs up if you think A comparison with 2, whether it's equal to, is going to be true or false. Thumbs up for true. All right, it looks like people are getting confident. So we'll just run that. Cheat code, it is. So these, we're going to go over quickly some of the most important and most used operators. So there's the double equal to's, which means equal to. There is exclamation point equal sign, which is not equal. So you want to know if this is not equal to 2. You want to know if things are greater. You might want to know if things are greater than or equal to. You might want to know if things are less than or equal to. And also you can just put those together with other statements. So again, if that seemed like a lot, go back and review that tonight. We will see examples of this today and use them in practice, okay? So let's see what's going on with that. So now let's go to this one notebook. So one Python basics. So again, if you want to come back to the repo, you can just click on this open in Colab. I'm going to control click because it will take over this particular screen. I don't really like that.
And if we could pause for a moment and get a green check if you are now, when you're in this point and when you are in the one Python basics. So give a green check when you're here or actually in the notebook. And give a red check if you need to see that, give that a red X if you need to see that one more time. If you could go through opening that in Colab one more time, Shara.
All right, so this here is the repo. And you click on it. You click on this badge here, the blue badge. And it should open right up to this. It'll find your repository because it is public. And then you just click on Python Basics. There you go. And it should do it for you.
Excellent. Great. And give a red check if you still are a little bit lost, and I'll put you into Breakout Room 1 with Preston. Looks like we're good to go.
Okay, good. All right, so we're actually going to build on what we just learned in the sense that we will be using the elementary data types to populate data structures. Now, data structures are things that kind of put together a bunch of data types. So as this says, we're going to talk specifically about lists and dictionaries because they are so heavily used in Python. They're just absolutely fantastic data structures, number one. But the other two will be very familiar as well. So tuples and sets, they will become very familiar after you learn more about lists and dictionaries. All right, so let's start with lists. So a list, what is a list? How can we think about lists? So the way that I think about lists is I tend to think about like office buildings. So if you were to walk into our office building, so which is formerly at the Wondery, we were on the 3rd floor, but that's neither here nor there. If you were to walk into our office building, you might know our location. So you might know that we are like if you're trying to find me, you might know that I am the 3rd office when you walk into the Wondery. I'm going to be the 3rd office. And you know that I'm the 3rd office, but you know that I will be in the 3rd office. So the index of where I am is 3, and then the value at 3 in that hallway will be me. So lists are operating in the same way. So lists are going to be where you have kind of an array of values, and each of those values has a particular numerical position, and you can find the value at that position by using the index. So let's apply that and see what that looks like in practice. So there is one caveat if you come from R and I think Java. So in Python, indices are 0 indexed. The first element is index 0. It's not 1, it's 0. Okay, so we're just going to see how that manifests right quick. So how do we create a list? What a good question. So this here that you see, this green thing here, this is a comment. You can tell that it's a comment based on its color, but first that it starts with this pound sign. So this is kind of for us. This is code that's for us. It doesn't actually do anything except for tell us humans things. But let's go ahead and create a new list. So we are going to call it new list. Actually, I'm gonna let's scroll up a little bit so you'll be able to see this in the middle of the screen. So we're going to call this new list. That's the variable name. And then we're going to assign some values to it. And the way that we indicate that we're about to use the data structure that's a list is we use these square brackets. So this says, hey, Python, by the way, we're about to make this data structure. It's going to be a list. Now we want to tell Python what we want to put in that list. So a list tends to be 1 or more elements. And so we're going to pick some specific values to put in this list. So we're just going to casually choose 0, 1, 2, 3, 4, and 5. So all of our list elements are separated by commas. And the brackets indicate that we're using a list. Okay. So to execute this, we can shift enter. Oh, please stop telling me I understand. So that's great, right? We didn't really see anything. We don't know what's going on really. We would just trust that this is in the kernel. However, if you want to see that with your eyeballs, you can always print it. So we said that we had this print function. So we call print. And the way that we use the function is we indicate with parentheses. So we're calling the print function on something, and we're trying to print new list, which is the name of our variable here. Okay, so we're going to shift enter that one. Oh my goodness, look at our list there. So now we can be pretty confident. We can feel very confident that our list has been stored because we're able to print its values. One last point is that there are other ways to show variables in a notebook. So for example, if we would have wanted to just kind of show this to show that the operation had succeeded, we can always type the name of the variable, thusly, and this will output that. So this is an output that is actually also stored in the kernel. This is something that is just printed to the screen. They're a little bit different because one of them has a specific method that's called on it, but that's neither here nor there. So those are 2 different ways that you'll be able to show things. Lastly, we talked about the type function. Actually, let's look at something. So we talked about the type function, and that if we ever want to know what the type of specific variable is, for example, let's say if we didn't call this new list, but we called it candy, that would be terrible because we wouldn't know what it was. That's neither here nor there. We could check and see what the data type was. And the way that we could do that is using that function that we just used. that we just learned, which is type. Again, parentheses to indicate that we're going to call it on something, and new list is what we're calling it on. Print that. So we have this printed, which is the new list here. And we also have the type output, like we did here, as list. Okay, wonderful. So something to note here in general when you're using Jupyter Notebooks, if you want something to print, you type print unless it's the last statement. If it's the last statement, it will be output. You can also, okay, we'll see more examples of that. But basically the story is, if I would have just did new list before here and then did type, you wouldn't have seen it. So only the last output is output for a cell. And these individual things are all called cells. Okay, so now let's talk about how you can find an individual value in a list. Okay, so the way that we can find a value is to indicate its index. So let's see what that looks like. So we have this variable new list, and let's say that we want the 0th item. So you'll hear me say 0th a lot. I just say that because when you say first, you don't really know, do you mean the 0th? But if I say 0th, you know that it is the 0, index 0. So let's see. How do we get that? We can do new list. So that's the name of our variable that contains the list. And we could say, hey, at index 0, what's the value? And so we shift enter and it returns a 0. So you may be a little suspicious because 0 was actually the value of our first element. Let's prove to ourselves that that is not the case. So let's make another list. So another list. And we're going to just add something different. So maybe 3, 4, 2, 5. Now let's see the value then. So we expect to see, what value do we expect to see? Hold on, let's see. I'll type this, another list. So what value do we expect to see after I run this command? And you can type it in the chat. You can, oh, perfect. Yes, yes, there we go. Let's see. And it is 3. So we can all feel good that this is like looking by position and not value. You ask for the position and you get back the value. Okay, great. And you can see here that the brackets, we're using the brackets to do indexing, but we also use the brackets to create. You can see that basically there's a difference in kind of usage. So when you're using brackets to create, there's the equal sign, but if you're using brackets with the list name, that means you're trying to access something in it. So that's just to disambiguate a little bit. There's a lot of different ways that we can access values in lists because there are so many different things that we need to do. So for example, you could use a negative index, meaning that you're like looking from the back. So for example, if we look at new list and we do -2, this will return that second index from the back. So not 5, but 4. Let's see. Another very interesting or very important function is this function called len. Len returns the length of a particular data structure. Okay, so let's see what that looks like. So len, okay, that's the name of the function. And then we use the parentheses again to indicate that we're going to be calling it and there's something to be passed in. Or there's not. Let's see there. But we're going to call that on new list. Let's see how long that is. Correctly, it says that there are 6 elements. Check if you guys agree with that. Are there 6 elements in new list? All right, we see some agreement. Good, good, good. 0, 1, 2, 3, 4, 5, 6 elements. Perfect. Great. So there are also some different ways that you can add values into a list. So one great way is through the append method. And so we're going to learn a little bit about, we're going to take our first foray right now into object-oriented programming. Okay. And we're going to use new list. All right. And then we're going to use this dot. Okay. So this is something that I love about Google Colab. So you see what popped up there. These are a bunch of methods that you can use. So methods are functions, but they're bound to like a data. We'll get into that. But these are the different things that you can use on the list data type. The list class. Look at all those cool things that we can do. And I love the Google Colab just gives you examples or it lists them for you. So when we want to append something, we can just call this append, and we can append some value. So let's say we want to append 6. All right. Okay. So that's interesting. We again didn't see anything. Let's see the behavior of just a moment. Okay, so I just clicked this thing right here, and then I just click the letter B. So I just click this little gray bar and click B to make a cell below. Sometimes I do that. It's just a little shortcut. When I want to add something a little bit new. Okay, so now let's look at new list right quick. So new list, let's see if the operation succeeded. Oh, it looks like it did. All right, so new list now is extended, right? What happens if you were to run this again? In place, you just keep appending. So whenever you're using this append method, when you're using these methods, you're actually modifying the list. So if you keep kind of modifying the list, it will keep modifying the same list. So be careful here. It's really great to be able to print out these things so it helps you know what you have done. This comes up whenever you try to like iterate through Jupyter Notebooks. So just keep in mind that these kind of things occur. And sometimes it's what you want, and sometimes it's what you don't want. Okay, one last way that we'll go over to append things is something you'll see in just a moment. So we said that the plus sign with numbers, so for example, 1 plus 2, that's not right. I just did the same thing again. Sorry. So error. This is saying that, what are you trying to do? This is a real number. How am I going to assign 2 to that? So if you see that, that's basically what it means. I don't know how to do this. It doesn't make any sense. What I was trying desperately to write was 1 plus 2. So shift enter to execute in 3. So we said when we use this plus sign, that means to add, right? But these are 2 integers. Those are 2 integer data types. What if we were to add data structures? What does that mean? Well, let's see. So as it were with lists, something really glorious about them is that when you add 2 lists, it also appends them. So for example, if we were going to take this new list and we wanted to add some more elements onto it. So maybe we want 8, 7, 6. We could do that. So now we have the same list value that we had, but now we've also appended 8, 7, and 6. So for you people that have texts and lists go great together for this reason. You can kind of smash these like different documents together, or you can kind of separate them. So this goes really, really well with text. And we're going to be going a lot into text today. So one last thing maybe about data structures, and then we will, you can cover the rest of these about further selection on your own. But one last thing that's super great about lists that maybe you might not experience in other languages is that they let you have differing data types within them. It's not just one data type. It can be many data types. I find that to be very exciting. Okay, so let's see what that looks like. So before we had new lists, so let's look at that. All right, and again, look at this. So look at these differences. So note that doing this did not append anything to the list. This is actually returning a different list. Okay. So this one maintained its own value. Think about that. It comes up when you're coding. Okay. So now we have new list, and we can add other data structures to it. So now we're going to add another list, right? What is that list going to contain? A different data type. So let's say string. Let's see if that works. Very exciting. Look at all those data types in one place. That's very exciting. This is very powerful. And just keep it in mind. So we're kind of just going over these things right now. But while you're processing your data, just keep these things in mind because they will assist you as you are going about out these tasks. So y'all go over these on your own. Basically, oh, I see a hand raised. But just really quick, go over these on your own. These are about how you can select multiple things in a list, basically by using a colon or a double colon if you want a step. We will see some examples of this, but kind of go in depth with this on your own after class. All right, I see we have a question. Do you want to put it in the chat or?
And if you have a question, after you raise your hand, you're welcome to go ahead and just speak. You all have the ability to unmute.
Also, I've hidden my meeting controls, so now I also don't know how to get them back, which is kind of unfortunate. So I can't actually look into the chat right now. So.
And the question was, can you append a string?
Can you append to a string?
Yes.
Is that a question? Okay. Wow. What a good question. The beauty of being in a Jupyter notebook is that we can try it out. So let's see. All right. So I'm going to, okay, where were we? Okay, where were we? We were looking for, hold on. We're going to dictionaries. So I'm just going to click on this cell again. B, right? This makes a new cell. Now let's make a string. Dogs are wonderful. Okay, let's see if that worked. I'm going to shift enter that. Okay, said the same thing back to me. I'm just going to take that as agreement from Google Colab that dogs are wonderful. Okay, so now let's see if we can append to it. Okay, dogs are wonderful. Plus, let's add something else. And cats are too. See how that goes. Shift enter. Oh my goodness, how wonderful. So it looks like you can add them together. Is this what you meant, or did you mean calling an append method?
The append method.
What a good question. Another good question. Try it again. I do this all the time. Okay. Just a second. So we were at dogs are wonderful. Dot. Oh, it didn't care. Sorry. I failed you. Okay. Let me try this again. I'm going to try this. If it doesn't work, we can, okay, there we go. So this variable cat is a string, right? And when we put the dot down, that shows us all the methods that are available to the type of string, right? So we can capitalize case bold center. Let's see if we can append. So these are in alphabetical order. So it doesn't look like append is a method that's specifically available for a string.
But if you had a list of strings, you could append another string. So you could have, you could do that, but you just can't append to a string.
Okay. All right, good. Oh, all right, good. Okay, so sorry, let's get out of here. So one last thing is don't do things like this. So for an example, I have dogs and cats on the brain because my pets are always attacking me during meetings and each other. So I just have these in my mind all the time. Don't do things like this. This dog variable is stored into cat. Like that's very confusing for the user or anyone who comes after you. It's awful. Don't do things like that. Okay. So round two. So we just talked about lists. Okay. Lists are special because they are mutable. And so that means that they can be modified in place. That is why we can call the append method on them, because we can modify them in place. Dictionaries. Oh, sorry, I missed the point of what I was trying to say. Also, they have a specific order. Their specific order is given by the index. Okay, so they're ordered by the index. Right? What if you didn't want that? What if the index is not enough for you? Knowing the position is not helpful. What if it would be better if the index was more like a key, like sort of like a dictionary? So how do we use dictionaries? So we have a thought in our mind. We're like, okay, what does the word list mean? Okay, that's not a good example. What does the word review mean? We look in our dictionary and we try to match the word review, the key review, with the word review in the dictionary. Once we see that word review, we can extract the value, which is whatever the value is. So the definition, right? So to look over something again. So when we use the dictionary, the key was review and the value was to look over something again. So it's like they're key value pairs. Well, that's exactly what they also are in Python. Python has dictionaries at key value pairs. You can look them up using the key to get the value. So let's see what in the world that looks like. Okay, so for example, let's make a variable called newDict. Okay, now we need to tell Python that what we want to make here is a dictionary. The way that we do that is using curly braces. Okay, this means, hey, Python, what's coming in here is about to be a dictionary. Then we need to establish our key value pairs. So maybe we're thinking about keeping, like, I don't know, some information about a class. So maybe the number of students, the average grade in the class, things like that. So let's see, maybe one of the keys that we would want to look up would be, this is going to be a string, so we use the quotes to show that, num students, so the number of students. So this is the key. How many students are there? We use the colon to indicate that the value is coming that's related to num students. And we're going to use 17. So one, we can see that we're able to use differing data types, but we are also to establish key and value pairs. So again, key, value. Okay. Maybe we also want to add average GPA. We can add that too. So our key value pairs are going to be separated by commas, and then our keys and values are going to be separated by colons. So, oh, maybe not. That's not even a real GPA, is it? Is it? I don't know. Okay. So here we go. So now we have two elements in our dictionary. We have number of students and we have average GPA. Now let's just take a look at that. newDict, shift enter. Okay, it looks good. It just shows us our dictionary back. So we can confirm that the values that we wanted were there. Something really cool that just happened to give us some insight into the way that dictionaries work. You can see that I gave it this order of num students average GPA, and it returned to me average GPA num students. So dictionaries do not have an inherent order. Their order is, like, they don't have an order. The way that you use them, though, is to use the key and the values. So they don't really need the order because you have the key. Okay, so how else can we add values to an existing dictionary? Well, it's going to look really similar to the way that we did things for lists. So we can have newDict. We'll have this bracket, meaning that we're about to, like, stick something in it. And let's have a new key, so maybe average grade. Scroll up a little bit so we'll be able to see this. Oh, too far. Oh, still too far. Maybe people are doing really great in this class. Average grade is 97. We're also going to print out newDict. Okay, let's see the difference here. And we can see that we added a new key value pair, and exactly like this. Okay, so we just said, hey, dictionary, there's going to be a new key here, and the value is going to be 97. It was like, that's fine, I'll add it in. So this is the way that we can work with existing dictionaries. And again, this is the way that we can create dictionaries. Curly braces to create, regular brackets to index or look up. All right, let's see. So these are just additional cells that work with adding other keys. If you want to take a minute yourself, we'll give you about a minute. Try to add average final. So this value, or sorry, this key, string key with value 80 into the new object dictionary. So we're going to give you about a minute, maybe a little less than that. Try that on your own, and then we will add that to.
There was a question in the chat. Do keys in dictionary data structures need to be strings?
They need to be string based.
Okay.
That's a good question. We can see.
And a second question, is it fair to say dictionaries in Python are equivalent to lists in R?
Equivalent is a very, very strong word.
Yep.
So name lists, similar, but the thing about name lists is they still have an order.
Yep.
But that's not true with dictionaries. So when you're talking about lists in R, that would be actually closer to like a series in pandas.
And under the covers, they look very different as well. The whole idea behind dictionary is fast access. So actually what's happening underneath is something called a heap, and it allows you to do very, very fast lookup. And that's why it doesn't have an order. The order is under the covers, not meant for human consumption. It's for speed of access. And Kathy, that was your question. Could you explain why the order in the dict looks like this? And that's it was giving it back to us in alpha, but it's not really alphabetized underneath. Underneath, again, it's ordered in a fashion that is all around fast access. So that's why it doesn't even pretend to have an order.
All right, fantastic. I would say drop it in the chat what your results, but unfortunately I can't see it. And at our next breakout room, someone can help me to try to bring back my Zoom meeting control. But does anyone want to read their results or their way of, okay, let me try this. So I am going to start typing and someone interrupt me if I start to go wrong, okay? All right, new dict. So we do know that this is the value or the object that we're interested in. And since I'm using a dictionary, I'm going to use these curly braces. And then I'm going to pass in this average final. And I'm going to set that equal to be.
Use the square brackets.
Oh, square brackets. Oh my goodness. Thank you so much. Average. Is there anything else?
It should be a string.
Okay, let's make sure about that. Okay, let's see. So I tried to run that. It says, what are you talking about? I don't know anything about an average final because we're trying to use this as a variable. So the person that asked that question, this is like the thing that I was thinking about. I'm trying to think about if this makes sense. Interesting. I need to think about that some more. The person who just responded was exactly right. This is not like a variable name. We want to use it as a string. So we can just highlight it, click one quote, and that will quote the highlighted area. Now, let's see.
So Induja, you are right. And Marcus also pointed out in chat that yes, you need apostrophes.
Yes, perfect. Yes, you guys are really good at this already. So we added all these things to our dictionary. Fantastic. All right. We can also, so far we've been adding things to the dictionary. We can also get things out of the dictionary. The way that we can do that is by using the keys that we supply. So it's going to look really similar to setting values. And we're going to use, again, our square bracket. And we're just going to pick a key that we know exists. So again, average final. And let's see. Wrong things. And again, I tend to press Shift Enter just in case you don't know what I'm clicking. And it correctly returns to us the value 80. So this is what we wanted. Fantastic. Okay. So now we've learned about lists. We've learned about dictionaries. These are exercises left to you guys to go over. Tuples and sets. Tuples are very, very close to lists, except they're immutable. Okay, and you'll read more about that. And sets are like lists, but they are, every value is unique, and you can perform mathematical set operations with them. And that can be extremely nice. So both of these things you will find to be very familiar. You basically use different types of symbols to indicate the kind of structure that you're creating. And then you're able to use the different functions as we described. Okay.
And Dr. Bell, do we want to take a 5-minute bio break
I
now?
would love to. And we can work on me getting my Zoom controls back. All right. I'll see you guys at 11:05. So in 5 minutes. We are going to try to use iteration provided through Python. And so one thing that we can do is use for loops. And so this is like just one kind of iteration that's available, but this happens to be a very popular one, especially in Python. Let's see. All right. So here's the thing. List and for loop go together super, super great. So let's start off with just the list. So we're going to make a new list again. And we're going to populate it with some numbers again. Okay. And let's see how we can then iterate over that using for loops. Okay. So maybe what we can think about is we know that this has all these elements. Maybe we don't know how long it is, but for some reason. Maybe, but what we do know is that there are a bunch of elements in it. So maybe we could say for each of these elements, do something. So for each element, do something. So for each element in this list, do something. Let's see what that looks like in code. Okay, so we said for each element, so L, we'll just call that L for now. For element in that list called new list, and we said we wanted to do something, we'll just print the element. Okay. As it were, this is the exact kind of syntax that you want for a for loop. So you have your for keyword to indicate that you're about to use a for loop. You have your in keyword to say that this thing is going to be, you're looking for things that are in this thing. And then this variable is kind of a dummy variable name. It just represents every element that would be in here. So this could be literally anything you want. It could be variable. My var. You do have to be just a little bit careful with reserved words. So you see in is turning blue, for is turning blue. Those are reserved words. You don't want to kind of use them. So for example, like list, if I were to say list in new list, not good. List is a reserved word. And this can, it can result in some weird behavior of assignment of list to a different thing. And now you can't use list anymore. It's a long story. So you want to avoid anything that's kind of highlighted in a specific color. And there's a list of those in Python's documentation. So we're going to call this L. I like L. And note that these two things, when you want to work with that element, you just call it by that name in your loop. Again, we have this colon to say that you're going to do all these indented statements while this thing here is true. Okay, so let's see what this looks like. Shift enter. It's just as we expected. For each element, what did we do? Print it out. Okay. So let's see what this looks like for our particular purpose. And now we're going to look at a reason why we care about lists at all. Okay, you're going to see one of the manifestations of list awesomeness. Okay, so let's say we have a sentence, and that is going to be dogs are cute. You might want to type it just like that because that represents actually every case. So upper, lower, and mixed case. And something that we can do is split this string based on something. So based on some type of parameter or some type of symbol. So by default, if you call the split method on a string, it's going to try to split on the spaces. So we're just going to go with that. And what it returns is a list of the elements, right? So we're going to get a list, and it's going to be, we're just going to call that sent list because, I mean, that sounds like a good name for it. We're going to do sentence dot split. And now let's just take a quick look at it to see what we get. Okay, let's see. Ooh, just what we thought. It returns each element where we have split on the spaces. Okay, so now we have a list of those elements. We have a list. Interesting. So what if we wanted to know then if each one of these elements were uppercase, lowercase, or mixed case? Seems like we would want to go over each element and maybe use that control statements that we used before on each element. Interesting thought. So turns out, again, that's exactly what we want to do. How can we do that? Again, for loop. So for, we're going to call this test bar, just so we can get some variation in the dummy variable that we're using to represent an element. So test bar in sent list. So for each of those elements, dogs are cute. What do we want to do? Actually, we want to do that function that we just wrote, right? Almost exactly. Let's see if we can find that right quick. This one, if it's uppercase, lowercase, or mixed, this is exactly what we want. We're just going to copy this. I'm going to put it here. Make sure we're tabbed. All right, you can see that this turned out not great. We're going to want to make sure to get our statements tabbed correctly. So looks like we don't want that. All these statements need to be indented for it to execute with this block. So let's tab that guy in, tab this guy in. However, we also need this to be executed based on this block. So let's tab this dude in, this gal in, and this one. There we go. All right. That's right? Let's run it.
There's a question in the chat that says, should we change the word word to test var?
Oh, this ran. So did we need to change word to test bar, or what happened here? Any thoughts? Careful. Very, very careful when you copy and paste. And this is why I keep saying be careful when you copy and paste. Because word is defined. It's defined in this notebook. It's defined in the kernel. So even though we're calling each test bar its sentence list, we are never actually testing test bar. We are only testing word. Word was lowercase dog, and that is why for every single time it says lowercase. Careful, careful, careful when you copy and paste.
So, and also just a quick comment about this too. using notebooks is really good for this exploratory programming. But even seasoned programmers, when they begin to sort of do this style of programming, make this kind of a mistake because you copy and paste so much. So you're going to be learning a little bit later about making functions, and whenever you have to retype things, maybe you should be making a function. But just know, even if you're a seasoned programmer and you're like, I know this stuff, this will happen to you because your style of thinking is changing a little bit. So yeah, you just have to be careful when you're cutting and pasting that you don't make this mistake because it's kind of invisible.
It is. It so is. Woo! Great advice. Thank you for that. All right. So like Zhao said, sorry if I just butchered that, we need to use test bar. Again, the dummy variable that represents all of our elements. We need to use that and test that. So we're going to take test bar. We're going to substitute it there and substitute it there. Now let's see. Run that. Up, and there we go. So this is operating correctly, right? So we looked at dogs first, because that's the first element in sent list. Dogs is all lowercase, so that's correct. Uppercase, correct. Mixed case, correct. So another point is that it's really great to do test cases, simple test cases, because it would have been easier to see that this failed because we had dogs are cute, and this should have had mixed results. Instead, it said all lowercase. So always use test cases to make sure your code is functioning correctly. All right. Oh, did I already skip? Did I skip ahead? Whoops. Oh, I think I did skip ahead. Sorry about that. I did this on accident. Sorry about that. You don't get to do this on your own, but that's okay. So this is how this can work in our situation that we described. Okay. So we're going to talk about something now. Iteration with dictionaries. Because we talked about the fact that this occurs in order. But how do you iterate over a dictionary since it has no order? Hard. Well, as it were, it does have keys and values. So you can iterate over the key value pairs. What does that mean? So something cool about the way that this for loop is set up is that it's not just like for this one thing in this specific thing. It could be multiple things on a function applied to this thing. What's that mean? So let's see how that looks with dictionaries. So again, we're going to use our for loop. But we know we don't want like one element. We might want both elements, right? We want both the key and the value. We can make that happen because we want to iterate over them together, right? So for the key and value in, let's see, we have new dict, right? I think we have that, yep. But how do we get the values? How do you get the pairs of key and value out of there? Well, you can use items. And this will return both of those things for each entry in the dictionary. Okay, again, we need this colon. And let's just print out what this would look like. So I'm just going to print the key and the value. Let's see. Okay, so this is exactly what we had in our dictionary that we created before. We had these keys and we had these corresponding values. So by doing it like so, you get these things kind of together and you're able to print them and use them as you like. There are also other ways to get like listed things. So you could do the keys or just get the values, whichever you prefer out of that. And then you can explore that a little bit after you do this period and look at some of the methods that are available. All right, this may be the last thing that we do today, but we will get to functions tomorrow if we don't have time, but list comprehensions. So list comprehensions are for loops-ish, but they just tend to look a little different. And not only do they look different, they look like super intimidating. but their power is very strong and they are so amazing. So you will see them a lot in documentation. People will go for a list comprehension before they go for a for loop, even though they are very, very, very similar. And in fact, list comprehension, oh, go ahead.
No, I was just going to say, list comprehensions to me is one of those things that they're actually really important because yes, they're a little bit complex, but they allow you to state something really important in a very concise way. They're worth the effort. I usually am like a fan of keeping things as simple as possible, but when you start working with things like deep learning and frameworks that we're talking about next week, you want to have things exactly like list comprehensions, so you can take a complex idea and boil it down to something pretty small, and that way it makes your code very concise and you can understand the big picture because a whole lot's happening here, a whole lot's happening here, and that way really complex stuff can happen in a short amount of code, but in an understandable way. So list comprehensions is different than most other languages. So this is now you're starting on the, it's all cool, but now you're really starting on the cool stuff here.
This is like the super cool. Thank you. Yeah, I totally agree, Jesse. That is great advice and great insight. Okay, so let's try. So we're going to come back to the sentence, and I've just provided it here so that we can use it again. All right, so this is going to be our sentence. We're going to split it, and it's going to turn out to be a list. Okay, let's say, for example, we wanted to make all of these things lowercase. We wanted to make each individual element of this list lowercase. Okay. So how will we do that with a for loop? So there's lots of ways that one could do this, but I will just show you one. So I can also demonstrate another function that you may find super helpful. Okay. So we can get the index and the value together, kind of like we got the key and value together for a dictionary. And the way that we can do that is through using this function called enumerate. So we're going to do exactly that. So we're going to get the index and the word in. So we're about to talk about the list that we're talking about. We're going to use this enumerate function, and we're going to pass in sent list. So we're going to actually just take a look real quick and see what this looks like. So we're just going to print end and word. Okay, let's see what we get to come up with. All right, so now we know that this is working, right? So we can get the index and the word for each element of sent list. And now we want this to be lowercase. So instead of just printing this, we need to do something to the elements of sent list and update them. So I encourage you to try this on your own and see if you can find some of the pitfalls so you'll know to avoid them in the future. But in general, what we need to do is update the elements of sent list. So sent list, we need to update a particular index. So the specific index that we're looking at. And all we're doing is taking that exact word and lowercasing it if necessary. In fact, not even necessary, we're lowercasing it, period. Okay, so how can we do that? We're just going to use another function from, we're going to use another method of the string class, which is just called lower. So we're just going to do word dot lower. And you can also print this out. So this worked exactly as we wanted, but it was kind of doing a lot, was it not? We had to enumerate, we had to get the value and the key, then we had to update it using the index. I mean, that was just kind of doing a lot to do, like a little in a way. So let's start over and try it with the list comprehension, okay? So let's run this one again. Shift enter, make sure that one runs, otherwise you're gonna have this. So make sure that you have this. I tend to like to just print it there before I get started, just to make sure. Let me scroll up a little bit. All right, so that is the way that we want. And now let's think again. Let's think about how a list comprehension should look. All right, so we're doing a list comprehension. the objective is to get out a list. What symbols do we use again? And also my chat is bad, so you can put this in the chat. What symbols do we use again to indicate that something is going to be a list? Ah, beautiful. Yes, brackets. All right, list comprehension means we're getting the list. So let's start with the list. All right, we got the list part done. Now we're just to the comprehension. Okay. What are we trying to do? We're still really doing a, so let's just write that part. So for word in sent list. Okay. So we want to do something with this, right? Maybe we want to emphasize what we are doing. So let's put that first in this statement. So let's just start off by trying to print all of the, not print, but show or return a list of all of the elements. So we're going to put at the very beginning what we're trying to put into the list. Okay. So the first thing that people see is the thing that's going to be in the list. So word. Okay. So for word and sent list, we want the element of the list to be word. Okay. That's it. We're just trying to get the same thing back in this comprehension form. Okay, so let's see what that is. All right. So this is actually your first list comprehension. You did it. So basically you iterated through each word in the sent list and you returned a list of those words. Oh my gosh, very exciting. So now, thinking about this, okay, what we actually wanted to achieve was, for each word in sent list, we wanted to return the lowercase version of word. How could we do that? Actually, we'll do it just like we did it here. So word dot lower for word in sent list. So this is the thing. This is the most important thing that we want to see in a list comprehension. So that's what goes at the beginning. Otherwise, it's a for loop. Okay, let's see how that goes. Oh my goodness, we have done it. We have done it. So this is what you should think of when you think of list comprehensions, okay? It's just gonna be a for loop, right? And at the very beginning, it's the thing that you want to have returned in the list. So regular for loop, thing you want returned. For loop, thing you want returned, okay? Okay, now, of course it gets harder, but that's okay because that's okay because there's still so much power in the list comprehension. All right, so let's see right quick. So number one, there is a difference between this one and this one. This one is that we just return, like this list comprehension is just output, but we could also update the original function, not the original function, but the original variable name with this, okay, but it would be a different list. But also we could just create a different list, right? So we could have lower list or whatever you want. You could set the original variable or you can assign it to a different variable. So we're just going to do this one. Okay. Just type that. Type that. Okay. And actually, I'm going to prove to you in this moment that it's still different from sent list. All right, there we go. So we have we have done the list comprehension. We have not modified the original even after we're done execution, and we can see the actual output, which is what we wanted. Okay, so fantastic. All right, now we're going to talk about two things that you can do to list comprehensions to get even more functionality that kind of comes with the for loop. Okay. One, the first is going to be a filtering operation. So basically, you only return certain elements that you're interested in. Let's see what that looks like. Okay. So maybe we only want words or elements of our list, which will be words that are lowercase. Okay. So remember, we're starting with sent list. If we only want lowercase, that means we only want dogs. R and cute, not. Let's see what that looks like. Okay. Again, we're just going to type this one more time so we can, that could just get out the way. Okay. All right, so we're going to type it again just to make sure. So we have 4, let's see, let's change it to a different dummy. Okay, L in sent list. Sent list has to be the same because that's the actual variable that we're operating on. Okay, we want to return the actual element. Okay, right? So we don't want to change that. We just want to return the element. So that's the value of the element. Okay, so now how do we filter out only the ones that we want to keep? Okay, so we want to return element or any element in the sent list, but only if the word is lower, right? Or if the element is lower. Well, let's just tell it that. Let's give that a try. So we want to return element for elements in sent list if the element is lower. So now we're testing the element to see if it's lower. It's true. Let's see how that goes. Oh. So it's working, right? So you could do filtering on your during your sentence comprehension okay, list comprehension by using this if statement to conditionally select elements that you want. That's very exciting, and you will see this a lot as well. Okay, so let's talk about what happens if we move this thing, right? Interesting. That's an interesting thought, right? Ponder. So maybe we didn't want to just filter. So maybe what we actually wanted to do is we wanted to, I don't know, lowercase something, or maybe you wanted to uppercase something if it was lowercase. Otherwise, return all the elements of the list. So you want all the elements of the list. It's just that you want to modify some of them. Okay. List comprehensions can help you with this as well. And the way is through a ternary operator, which is very similar to moving this guy elsewhere and then adding an else. What in the world did that mean? Okay, let's see. Again, list comprehension, list. Also, by the way, always remember that this is a list comprehension, so you need these brackets. If you type that code by itself with no list, it'll be like error, 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 and you will not understand what's going on. Add brackets. Okay. All right. So let's see. We said that we want to return all elements of the list. So that at least means we want to iterate over the list, right? Start with a for loop. So for L in sent list. Now we want to return all of the elements. But for some of the elements, if they are lowercase, we want to uppercase them. Okay. This means we are modifying the value conditionally. What's that going to look like? Well, we said we wanted to return the uppercase. So L dot upper, when are we returning upper? If L dot lower equals true. Okay, but then how do we get the other elements of the list? Because this will only return the ones that are lowercase. What is that other thing that we can do? We have if. What other kind of control statements do we have? If. Are there any other things that we can add to that if statement if we want to have something that's binary or mutually exclusive? What else might we be able to put there? Yes, else. Else. So if it's lower, we want to return the upper. Otherwise, we want to return itself. L. Okay. This is a ternary operator. Sort of. So again, just to state what's going on in this piece, we want to return the element dot upper if it's lowercase. If it's not lowercase, we just want to return its normal self. And we want to do this for all L's in this list. All right, let's see what that's like. I forgot what we did. Oh no, I think I messed up somehow.
And
L. Let me just look.
oh, and Preston was pointing out maybe that L dot lower should be L is lower.
Thank you. Thank you. Absolutely right. That's right. So L dot lower, lowercase of things, is lower, test if they're lowercase. All right, and there we go. You saw me remove this true part because you can. But it is kind of nice to have the true there sometimes. This is more concise, but thank you for that, Preston. I was like, huh, what is happening in my life? No, this is perfect. So you can see the difference here. So L dot is lower. This is true for dogs. And so we uppered that. Otherwise, R and cute are not is lower. And so we return them as themselves. Okay. Thanks again, Preston. You saved the day. All right. So lastly, we do, I think oops. Sorry, I think I skipped ahead again. Sorry about that. But you can find the correct match to the words in the solutions. But now, I think maybe for the next maybe 8 minutes, you can try this on your own, the in-class exercise. And then maybe we'll come back and we'll discuss what we'll be doing on tomorrow. And then we'll start tomorrow by going over these results. Does that sound okay to everybody? Oh.
And would you like people to work individually on this and then to have some people share, or do you want to have breakout rooms?
I would love to have breakout rooms.
All right. I've set up breakout rooms. You're going to be invited into a breakout room. Remember the instructions. We suggest that one person share their screen and sort of code for everybody, and have another person who will take the results and put them into the document that we shared earlier. So we're just going to have 8 minutes. We're going to be kind of quick. Then we're going to come right back here, look at a few answers, and then talk about what we're going to be covering tomorrow. And I will be opening the rooms now. I'm going to automatically move everybody into the breakout rooms, and we will be there for 8 minutes.